Hi everyone, my name is Omar and I'm going to present my work about developing effective Oracle to reduce patch overfitting and automated program repair. And as an agenda this talk, uh, I will first describe the key contribution of this paper, which mainly talk about the correlation between patch overfitting and automated program repair and the program or the proper program termination and other aspects related to the fault or to the bug that is being repaired by the APR system or the automated program repair system. Then I will describe a rigorous patch validation system to mitigate or reduce the effect or impact of overfitting in program repair, discuss the feasibility of the proposed approach. How can we implement this approach using the present or available formal analysis tools that is already available in the literature? How can we integrate them so we can address the overfitting problem in automated program repair? And finally, I conclude my presentation. So the key problem we address in this paper is the patch overfitting in automated program repair. And this problem mainly happens because the traditional APR tools use test suites or test-based validation strategies. And simply, it assumes the availability of a limited number of test cases, validation tests, and it uses these tests to validate the patches until the tool finds or identify a patch that passes all test cases. At that time, it declares that it finds the patch that is feasible or that is good, and then it produces that patch as a good patch. However, the test suite only covers part of the program behaviors, and it is not a comprehensive or a complete specification. And this approach, test-based APR or automated program repair, often lead to overfitting, which means that the patch passes the available validation test, but doesn't generalize or doesn't scale. So you might be able to find a patch out a test that is outside the test suite that makes that patch to fail. So how to how to improve this patch validation process and how to detect and mitigate the overfitting problem in automated program repair is the problem that we started in this paper. So our main contribution, first we identify there's a strong correlation or relationship between the automated program repair challenges, particularly the overfitting problem and the program termination behavior or the check for proper or correct termination of the program. So if we have a methodology or an approach to check whether the generated patch can terminate for each possible run, we can detect all overfitting patches and we can reduce the probability of producing or generating overfitting patch by APR tools. The second key contribution is that we develop a rigorous patch validation system that doesn't only rely on test suite or O output, but we add two extra validation or Oracle validation oracles. One is O halt. As I mentioned, it checks the halting, the proper or the successful halting or termination of the patch using some termination provers or some program analysis techniques like termination provers, and OAP, which is an oracle that check whether the erroneous behavior associated with the bug has been eliminated in the generated patch. So we also apply some tools to check whether, for example, if the bug in the program causes the program to crash or to hang or any other or generate some exceptional error. So we check whether that error has been eliminated in the generated patch to ensure that the patch is not overfitted or the patch is correct. What is the correlation between an APR and program termination? Actually, the correlation is very strong, and these two problems are very related. In the sense, we can transform the automated program repair into a program repair into a termination repair or into a termination problem by ensuring that the program can successfully complete its execution. Then we can mitigate the risk of introducing new errors, particularly the crash error. So if the program terminates successfully, then there is no run in which the program crash, or there is no run in which the program hangs forever. Like we don't have infinite loops, we don't have memory violation error, and a list of errors that cause the program to terminate abnormally or even to fail to terminate. So termination check can be more general than merely assessing the program functionality by just checking the output for certain inputs. No, we can check also the termination, the successful or proper termination, and we can assure that the program is free from a wide variety of bugs, including crash and infinite loops and the other memory violation problems. The feasibility of the approach is feasible because there are a wide variety of techniques and formal analysis tools that can be employed to check the absence of erroneous behavior and to check the proper termination tool. One of these are termination provers like Approvee, others like software verification tools or software model checkers like CPA checkers, Pathfinders, and from C, some for C programs, some for Java programs. And there are also complexity analyzers. You can check with the absence also of some performance, but assuming you have the upper bound for termination, so we can check that each run can terminate within a specific bound or specific time bound. So in conclusion, uh, um, we say that test suite are not the only option for patch validation, and the community should look for new, different, and more effective oracles to address patch overfitting. And termination check should be key part of the APR patch validation process. And finally, we add two extra validation criteria or oracles to check the validation or to verify the correctness of the patches. One of them, the absence of the erroneous behavior, and the other is the check of program termination, proper termination. Thank you. This concludes my presentation.